was it wrong? I'm so what's that video?
Hello, good morning. Hello, good morning.
Yeah,
Can
good
anybody hear me?
morning.
Yes,
Good morning, sir.
please. My apology. Yes, I just sent a message on the group. The meeting, sorry, we'll comment lecture in 30 minutes time. I little challenge, so I'm now on my way to the university. So hopefully in 30 minutes time I'll be in there. Please,
Oh, okay.
just give me some little time. Yeah, please. Hello, good morning. Hello.
Good morning, sir. Good morning, sir.
Morning, sir.
Yes, good morning. I was here since, but to get access to the room was proving very difficult. I actually kept my time of that 30 minutes. So it's okay. We'll start this. I gave you the slide yesterday. I don't know whether most of you were able to have access to it, to look at the water qualities. Yesterday, we were able to look at soil quality, and I believe that most of you will now understand how to assess water and soils and soil quality using soil index as well. So today we're moving into water. The United Nations Convention in Rio de Janeiro 2010 made a pronouncement that access to water, so access to safe water, not just water, safe water is a fundamental human right. So by extension, every human being on this earth has a right to have access to safe water. And safe water in this context, we're referring to the water that is free from any contamination that can cause any harm to anybody. So as we digest through this work, you will understand in detail most of the parameters that we consider water to be safe. I hope almost everybody is in the lecture room now. I know that most of us. Hello, unmute your mics. Oh, thank you. So we please try and mute your mics. The noise is interfering with what we are doing here. Please. So on the slide I shared yesterday, we're starting with slide 70. Whose hand is up? Okay. Who did the
Thank you.
Francis? What is happening?
Yeah. Good morning, sir.
Yes, good morning.
Yeah, I'm not seeing the slide for water, for that of water is the soil.
The one I shared, I forwarded the slide on the platform on the group. I sent the slide yesterday. You didn't download it. Hello?
I've checked, I did not see it. I've checked, but I did not see it.
Uh-uh.
Sir, you didn't share any
Yeah.
slide yesterday.
Wait. Excuse me. Let me. I did.
Is that of soil health and quality that's here?
Uh, should it be that I shared on a different platform or what? Okay, this
Maybe.
platforms. Yes. Oh, I say prof. Well, I say prof. Morning, prof. Thank you, sir. Yes, prof. Okay, please, can you check now? Hello?
Yes, we have
Hello?
seen
Yes,
it.
let's check
We
it.
have seen it.
Oh, please. I'm very sorry about that. I shared it. I thought that it dropped. So I'm very, very sorry about that. Oh, and this is the challenge with network, because I promise I try to keep my promise. So just scroll down to slide 70. Just scroll down to slide 70. If you are there, let me know, then we'll start.
I'm there, sir.
Who else is there? Slide 70. Simon, are you there? Udele Francis.
Sir, the slide
Francis, are you there?
what I give you is 54 pages. Hello, sir.
Let me hit you fully.
Hello, sir. What I
Aqua
give you
Samuel.
is 54 pages, not up to 70.
Sir, this slide is not up to 70.
It's 54.
But I saw where water started from, so that was just why I stayed.
I don't buy for Sheba Kava Guma Shima and give us a Taga. Then did the door open. This is a private residence. And we did have taken it to the public place now.
Somebody say that that is on the.
Water started from slide 27.
26. From 26.
No, it's
Okay, then
27. It's
And it's
27.
not 54.
oh gosh, that means the one you have is different from the one I have here. But okay, let us be on the same page. That one you have, what is the content of the slide, so that we'll be on the same page.
It's 54 pages, sir.
There's a pictorial. There's a pictorial there containing so confusing
One
categories of
person should stop.
water use.
Huh?
It contains categories of water use.
Good. Yes, that is where we'll start. Yes. So that is the categories of water use. Yes. So please, we'll start there. Once again, good morning. I welcome all of you to today's lecture. In that picture, those images there, we have diverse applications of water, how water is used. So you can see public supply. The first one, the second one there is domestic, one used in our homes. Then for irrigation of farms, for thermal electricity, like the one we have up there, you can see. Then industrial use, look at an industry there. Then for mining, our livestock too, and aquaculture. So those are the categories of water used there. Okay, now let's go to the next slide. Since your number and I is not the same, this thing I will be talking of next. So the next slide is different uses of water in specific fields. So you talk of domestic use of water, where water is used for drinking, bathing,
cooking, washing dishes. Then in agriculture, irrigation, water is also used. Then for industrial uses, so those pictorial images there, the next slide tries to make justice to them. So please, next slide. Next slide. You have sources of drinking water. Now, water, we have surface water and ground water. So we talk of surface water, we refer to the water found on the surface of the earth, lakes, streams, oceans, seas. So all these are surface water. And when you dig the soil and you get water, we refer to that as underground water or groundwater. We have well and boreholes. So on the underground, we have aquifers that store water underground. And the water table also varies. Some places, you just dig a little, you get water. Some places, you dig very deep, you get water. So the water table varies. Now, the next thing they say, groundwater under the direct influence of surface water. Now, when rain falls, water percolates, it moves down, it goes through the soil profile, it passes through different layers of soil profile. And at each layer, there is a significant amount of filtration that takes place. So the total dissolved solids are held back to a larger extent, and even some microbial organisms are also held back. So by the time this water percolates down to the almost some certain depth in the soil, you discover that a lot of these impurities will reduce drastically. And that explains why when you fetch water deep down, it appears, let me use the word appears in code, to be clean. Yes. You only ascertain when water is clean if you have actually analyzed this water. You test the water to know that what is clean. Next slide. Next slide. Next slide there is groundwater. Groundwater. Now, groundwater is easily the most important component and constitutes about 2/3 of freshwater resources of the world. And if the polar ice caps and the glacier are not considered, groundwater accounts for nearly all unstable fresh water. If you look at the world, the Earth has what we call polar regions. What are the polar regions? I want us to also participate just like this yesterday. What are polar regions? Anybody? Can I see your hand up if you know the answer?
The North Pole and the South Pole.
No, Oga, let me see your hand up. You can't just be talking. This is not Market Square. This is a classroom. I know you know it, but raise your hand so that I give you audience. Otherwise, the class will be rowdy. Hello? Yes. Francis. Udele Francis.
Okay, sir. Polar regions. That is, you say those icy realms. That is extreme planets. The north and the south polar regions. That is the Arctical and Antarctica.
That is beautiful. Yes, if it's in the secondary school, primary school, I will say they should clap for you. But if they clap here, nobody will see. Yeah. Thank you so much. That's a beautiful and excellent answer. I'm so impressed. So I hope all of you heard what Francis Udele said, that the Earth has the north and the south poles. And those poles, we have the Antarctica and the Arctic. So these places, the upper.
I see here. I can't hear anything from this side. Is anyone hearing?
No sound.
I
No
can't.
sound at
No,
my
we can't
end
hear on
as
our
well.
side. On my end, no.
I'm very sorry. I just discovered that network threw me out. So please, when you last heard me, what was the last thing I said so that we'll be on the same page?
We were
Anybody
talking
to
about the polar regions.
pardon?
We were talking about the polar regions.
Okay. Thank you so much. So do you know that all this while the network just threw me off? I just discovered that I was off. Okay, so yes, I said what Francis said is very correct. So I was trying to explain further that these regions, they're not as south poles. They are very, very cold. And I was trying to give an explanation, an analogy into why it is so. It's because the sun rays, as here in tropics, every day you see sun rays. That don't happen in the polar regions because it is, let me use the word, up to extreme. So the rays of sun hits mostly within the middle, the equator. And so we are crying of global warming today, greenhouse gases, global warming, climate change, that these greenhouse gases, methane, water vapor, carbon dioxide, all these gases, they have the potential of trapping heat. And so when air moves, it takes this round the world. And as reaches those regions, the variance in temperature will cause the ice to melt. You know that ice melt at water freezes at 0 degrees centigrade. So when this water melts, or when the glacier melts, it increases the volume of water in the ecosystem. So I was also trying to explain again the next sentence. That's this paragraph, that water is used for irrigation purposes. Then for livestock farming too, and also industry. We discussed that in the other slide. Then we're trying to differentiate between groundwater and surface water. And the first paragraph there is saying that for surface water, any contaminant that is found there can easily get remediated, can easily get, can easily be recycled, removed, sort of. But for groundwater, it is difficult. The reason being that it is slow. The more water on the ground is very, very slow. Then secondly, the degree of chemical and chemical independence between water and the containing material. Then I ask a question that what is physicochemical parameter? What is physicochemical parameter? What is happening? Yes, what is the chemical parameter?
Hello, sir.
Okay, yes, Francis. Yes, you can speak, Francis.
Okay, Simeon that is talking, sir. Simeon.
Okay, Simeon, okay.
Yes, in terms of water,
Yes.
when we're talking about the physicochemical parameters, we are talking about the physical parameters of water and then the chemical parameters of water. And those parameters, physical ones, include the color, the taste, the odor. And then when it goes to the chemical parameters, it has to do with the pH of water, the amount of suspended particles, and dissolved oxygen, and the rest of that.
I like this class. So what she said is correct. Thank you very much. Okay, so let's continue. Let's continue. Then we have what the next slide, please. The next slide. The next slide is on water characterization. Water characterization. Now, rivers and streams of all sizes, from source to tidal limits, then the influence of saltwater intrusion, canals, and interconnecting river system are all included. So they are characterized by unidirectional current with relatively high average flow velocity ranging from 0.1 to 1 millimeter per second. So that is the for rivers and streams. What is the speed? What is speed? How does water flow? That is, you're trying to measure the flow or the current. Let me say this, it will help you because education, knowledge is never a waste. Do people, well, let me ask this question. Why is it that similium fly, the vector of onchocerciasis, what we call river blindness? Why is it that it's not everywhere that you find people with river blindness? Why is that? It's not all people that stay close to the river suffer from the sickness called river blindness.
No idea, sir.
So if you say you don't have idea, Francis, what do you say? Francis, I thought you were saying something. Okay, good. We are here to learn.
Yeah.
So let us share this knowledge so that it will help us all, okay?
Yes. I don't understand the question.
Okay, the question is this. Why is it that not all people that live or reside close to a river suffer from river blindness, what is known as onchocerciasis, that is caused by onchocercical blood bolus? Anybody?
Thank you. I'm sorry. I'm not taking for karate. Go.
Who that taking the karate? Please mute your mics. Okay, Alan. Alan, your hand is up. I can see you.
Okay. Yes, morning, sir.
Yes, morning.
It is because river blindness is caused by an insect bite. These flies they call black flies. It is not
Yes.
actually the river that causes that. It is the insect. When you get bitten by the insect, that is when it affects you.
I said that earlier. Now I said it here that it is caused by oncortical blood bolus, and the vector is that black fly is called similium. It's called similium. That's the name of it, black fly. So my question now is this: why is it that not all people that stay close to the river suffer from river blindness? because it is called river blindness. Why? Because it is believed to be associated with people that stay close to rivers, and it's true. So why is it that not all people that stay close to the river suffer from river blindness or onchocerciasis? That's my question. Okay, yes, Simon.
Hello, sir.
Yes, Simon.
Yes, sir. From the little knowledge I had, I understand that the parasite breed on the rivers that flow very fast. So those rivers that don't have high speed of flow, the parasite will not survive there. It will not be able to brood there. But those rivers that flows very fast, it can enhance its mode of breeding. So it only affects those people that are located in rivers that flows very fast.
Okay, thank you for that contribution. Ikum Sedon hand is also up.
Okay,
Ikum,
sir. I think I'm talking. I think it
Okay.
also depends on individual immunity strength.
Okay,
Yes.
and that is your perception, right?
Yes,
Okay,
sir.
let me give the last audience to Freda Yerson.
Yes, sir.
Then
Good
we'll wrap up
morning.
on that.
Sir, I believe that not all the black flies have the are infected. So there's a possibility that a black fly might bite someone, but it might not have it might not be that black fly that will I say it's carrying the the illness, the ailment.
Okay,
So
so
it's
thank you
possible.
so much.
Yes, sir.
Then let Francis also say something. Then we'll stop there and proceed.
I think it's not everybody that will be close to the river that the black fly will be beaten now. And also,
No.
yeah, it's not
Okay,
everybody
okay.
that will beat
It's okay. I appreciate each one of you for your inputs, but the correct answer is what Simon said.
This one.
Are we still hearing?
No sound. Oh.
Which one is this?
Sorry, I just have to take that call because I have a lecture now with undergraduate students, so they were calling me, so I have to tell them to exercise patience. Now,
15,000.
the correct answer is what Simon says. You see, Similium, which is a black fly, the larvae thrives or survive only in fast-flowing rivers or streams. What the reason is because as water is flowing fast, it's enriched with enough oxygen. So as it's flowing, it's let me use the word engulf, or let me use the layman term, swallow air, so you get it understand better. So it's rich in dissolved oxygen. And so this dissolved oxygen will enable the larvae to what? To survive and metamorphose into what? The fly. So if it's a water that's not flowing fast, the larva cannot survive. And as such, you won't have what? The similon there. That is why not everybody that is close to the river suffer from what? River blindness, except people that are close to rivers or streams that have fast flowing waters. Like in Benue State here, if you have been to Chatoka, you will en route for the place they call Satikyo. And if you look at that stream, is it Amile? What I don't know that, but if you look at it, it's rocky. The soil is rocky, and so as water is flowing, you visibly see the force it flows with. So the insect lay her eggs there and they hatch very well. So people that stay close to that place, they are bitten by that fly, which now injects the worm into their body, which it's thread-like. So it will now migrate up to the pupil of the eye and block it, and light cannot penetrate, and person becomes blind. So when you go to the hospital and you are giving mixizan or what? Yes, mixizan. It helps the person because the mixizan will destroy the uterus of the womb. So the uterus of the female, or the womb itself, the womb that causes blindness, and she cannot lay eggs any longer.
Any audio?
Please, I'm sorry about that. This undergraduate, I told I will attend to them later. Okay, so let's proceed. Then the next one is what? Lakes of all sizes and types, including marshes and bogs. They are characterized with what? With a low average current of 0.01 to 0.0 millimeter per second. So if you look at the speed, it's reduced. So the speed in rivers and streams are faster than that of what? Lakes. Then groundwater, shallow or deep, phreatic or confined groundwaters are characterized by a rather steady flow pattern in terms of direction and velocity. So the average flow velocity commonly found in aquifers range from 10 raised to power 10 to 10 raised to power 3. So it is what? Very, very, very slow. Okay? The reservoirs, floodplains, and marshes. So some marshes, the water is just stagnant there. Yes, you don't notice the flow at all. So this is how water is characterized based on the body where the water is found. So you don't expect the water is found in marshes to have the same flow rate with the water with that of rivers and streams, because rivers and streams are bigger. They are bigger, so the water flow there is higher. Now look at River Benue and River Niger. You can't expect these two rivers to the velocity there to be the same with maybe the lake that passes at the back of your house or houses. Next slide, please. Are you still hearing me?
Yes, sir.
Okay.
Yes, we can hear you.
So thank you so much, because most of you have behaved maturely, and I love that, because once truly the gospel truth is when you unmute your mic and you're conversing with somebody else, maybe on the market square, your house, your children, it interferes with the quality of lecture being delivered here. So that's why we are happy that you mute your mics. So thank you for that cooperation.
Hello, Doc.
Now, yes.
Doc, I tried to lift up my hand, but I don't know whether you showing. This is Oche Simon. Hello, sir.
Okay.
I tried to indicate by reason of each time I do that, I don't know whether you are noticing it's showing. I don't know what is happening.
I'm not seeing. The one I'm seeing here is.
So that's why I had to interject you. You know, sorry for that, because I tried to
Okay.
indicate, but I want to ask whether is dams are these sorts of drinking water dams? I don't know whether dams can be categorized as source of drinking water. The dams.
Yes.
And if they are, then I don't. Why are they what do we categorize? Is it underground or surface water? Dams. Because it's made man-made stuff. That's why I'm asking. Hello, sir.
Where do you find dams?
I don't know, because it's like.
Excuse me, how won't you know? Where do you find dams?
That's why I'm asking. Anyway, we'll find it.
Listen to me now. You ask that question. So some questions you need to ask answer them by asking the person that asked such question. How are dams formed or produced?
They are produced by man, as in created by man, by
How?
we. By a form of like dredging, or sort of dredging to create the dam. I think like dredging or sort of. Hello, sir.
So where is the water coming from?
Since we drill borehole and drill the one coming from underground, I don't know whether at filter water. I don't really. That's what I'm asking.
Please, sir, can I comment?
Yes, comment.
Yeah,
It's a flowing
dams,
river.
like the one we have in my environment, is created from water that is flowing. Perhaps because in my place we have a waterfall. So when
Okay.
the water is running on top, just like we have the normal stream, is flowing and is falling. The water have a lot of current. So
Okay.
for you convert this water to other, like the make it to use the water to generate electricity, they decide to build a dam with it. The water
Okay.
there is surface water because it's
Okay.
flowing. People who go in there and fish. There is how the site is being designed, shows that the water will be channeling to a particular place with high pressure. Once it's poured down, the technology applied to that at that stage now generate electricity. That
Okay.
particular water at that point, at the source, might be good for drinking,
Okay.
but subject to analysis. But
Okay.
once it pours down and generate electricity, it's no longer suitable for drinking, except after treatment. Perhaps it
Okay.
might be used for other purposes apart from drinking.
Okay. Thank you. Mm.
Okay. I appreciate Akpan.
Yes.
Is Akpan that said that?
Yes, sir.
Yes, sir.
So Akpan, I appreciate you so much for coming to rescue me. Huh?
Doc.
Yes. Thank you very much.
Thank you, Doc. Thanks, sir.
You see, it's good that we are here to share knowledge.
Yes, sir.
Why I asking that question is this. You see, we just finished explaining about surface and groundwater. Now, most rivers take their source from the mountains. Yes, water gushes out from those places and flows on the surface. Now, a dam is an artificial water reservoir. So humans, they will build a wall encompassing a large landmass to protect, to prevent water from what? Maybe the word escaping. So this will store water, large amount of water, which will now be used for different purposes depending on what it is built for. Some places is used for what? For irrigation. That he explains some places used for what? To generate hydroelectricity, like the Kanyi Dam you have. So there's a waterfall too in my community, so that if you may be even 20 kilometers away from the waterfall and you still be hearing the sound of the waterfall to tell you how deep that waterfall is. So some places can be converted to produce generate electricity. I remember our senator then made a proposal to the federal government to come and site electricity distribution plant there, but I don't know what has happened. So the next slide is water quality. Are you all there?
Yes, sir.
Yes, sir. We are
So
there.
thank you.
Okay.
Yes, sir.
Now,
Yes, sir.
so thank you very much. See, yesterday we're looking at soil quality. And then today again, we are here with another thing, quality. So this one is more detailed because there's so much concern about water. The reason being that we consume water every day. Every day of our lives, we use water for different activities. Every day of our life, we must have. It's a must. Otherwise, we cannot survive. If you go testing from morning to evening, your sister will try to tell you that, yes, please, I need to be hydrated. So some person is sitting to know about with bottle of water. It's not that it's to show off, but they know how important water is to the system. And it's also a route through which most diseases enter our body system, and some persons are killed. So this is a very serious matter. That's why we have to understand this and take it very seriously. And I'm not saying so it's not important. It is. But this water quality is of more concern to all of us. So the decline in water quality has become a global issue of concern as human population grows, industrial and agricultural activities expand, and climate change threatens to cause major alterations to hydrological cycle. Now, what that means is this: people are giving birth to children every day. Population is increasing. The demand for resources is high, and the resources are scarce. And so you could see conflicts. There are crises. People are competing for resources. This is land, this is my land. Don't come here. This is my water. Don't touch it. So heated to what people normally, give without having a reason. Now it's no longer like that. So people even waters of people who come there and say there's no water. I mean, they may have the water. They will have to maybe lock their wells or lock their boreholes. Why? Because they are trying to conserve this water from others not to touch or use. So climate change has caused a serious change, has caused a serious alteration to the normal cycle of water around the world. I told us earlier that the greenhouse gases that have the capacity or high affinity for trapping heat. It's just like marriage. You look for a woman, you court a person, you get married to the person. And so you must have affinity, you must have likeness for that person to get married to. So just like that, when heat is emitted into the ecosystem, these gases love heat, and they go and marry her and say, "Come, can you be my wife?" Heat will say, "Yes, I will be your wife." And they say, "Okay, let us go." So anywhere they go, they take heat with them. That's why if a woman is cooking in the kitchen and she's using firewood, and then or even the gas where the room is blocked, there will be heat. There will be heat in that environment, especially for what do they call it? Charcoal, sorry, firewood. And windows don't have good or good hot. This red round hot they use at the villages. When a woman comes out, you see her. She is crying. It's not crying. It's the smoke and the heat. You see her sweating, visibly sweating. Why? Because of the heat that generated from the firewood has been trapped by the carbon dioxide that's coming from the wood being burnt. So just have that picture back in your mind. When that type of heat goes up to the polar regions where you have ice that has been there for centuries, it's not melting. So it will cause a change. It will alter the cycle of water around the world. That's what that first paragraph is talking about. So industries are coming up every day. Agricultural activities are coming up every day. So you can't go and tell, especially the capitalist system, where people are after making money, they're after profits. So they don't care about what happens. As far as they make their money, they're cool. So you will discover that most of this industry that produces most of these greenhouse gases, they're after profit making. So they don't care how they are going to reduce or control the amount of these waste that are being emitted in the ecosystem. If you go to a developed country like UK, for instance, most of these industries there, they have a threshold. They have an amount of pollutants that have been permitted by the United Kingdom government to be emitted into the ecosystem. No matter how rich you are, no matter your desire to produce goods, you can't exceed that limit. So they do that. It has helped what? Control the amount of pollutants being released into the ecosystem. But other developed nations, that's not done. So if I can produce 10 tons or 100 tons of goods every day, fine. I'll do it because nobody's monitoring me. Now, the second paragraph talks about that globally, the most prevalent water quality problem is eutrophication as a result of high nutrient loads, mainly phosphorus and nitrogen, which substantially impairs beneficial use of water. Major nutrient sources include agricultural runoff, domestic sewage, and a source of microbial pollution, industrial effluents, and atmospheric inputs from fossil fuel burning and bush fires. Now, let me explain further. Okay, before I explain, let me ask, maybe somebody may know what I want to explain. Yeah, so what is eutrophication? Thomas, Inusa. Yes, Thomas, Inusa.
Yes,
Can you say
sir.
something?
No idea, sir.
No idea?
Yes, sir.
Okay.
No.
Any other person?
Yes, sir.
I think it's
Okay,
a
Simon.
Okay, so it's a situation where a river or a water body become overloaded with nutrients, particularly nitrogen and other heavy nutrient materials.
That's all. Simon,
What I
that's
can
just
say,
what Simon is okay. I thought I wanted to say something different from what I just said.
No, sir, it's just the richness of water with nutrients. When water becomes heavily loaded with nutrients.
Okay. Any other person?
Okay, sir. When this happens, you see that there's some these aquatic plants that grows in the water.
Okay.
I think that is what I have to answer. Yes, sir.
Yes, yes. I love that contributions. That's very beautiful. Especially this last segment just made. It's very, very impactful. Now, I want you all of us to be on the same page. If you look at yesterday, we were looking at soil nutrients. Do you people remember yesterday we talked about soil nutrients? And we made mention of primary nutrients. So what are the primary nutrients we discussed yesterday? Can anybody tell us?
So we talk about nitrogen, phosphorus, and potassium.
No. Is carbon there? Carbon is not there now. Is carbon a primary nutrient? No.
No, sir.
The primary nutrients there are. Oh, chairman,
Nitrogen,
wait now.
phosphorus, and potassium.
Chairman, wait.
Okay, sir.
Chairman,
Sorry.
wait. Thank you. The primary nutrients we mentioned today, we say we have nitrogen, phosphorus, and potassium. So those are the three primary nutrients or three major nutrients. Let me use the word major now, so that you get that really stuck. These three are very, very important. Others are also important, but these three are very, especially the first two are the limiting nutrients. They're like the father and mother of plant nutrients. So, if you have people cultivating near the water bodies, and people will apply fertilizer, they say, okay, just apply 1 spoon of fertilizer per stand. The person say, I beg, get away. Do you buy? Is it your money? Somebody will apply 1 mudu of fertilizer per stand because of what? It's our own money. Now, the plant cannot utilize that fertilizer all at once. Or you apply it in the required dosage or quantity, and it rains heavily. This may wash this into all the surrounding water body. That is why, especially during rainy season, if you pass through River Benue, you see it so muddy. The turbidity is so high. And you may visibly see water hyacinth, the water lily, or water lettuce flowing on the water. So as he earlier observed, you will see some aquatic plants growing on that water. Why is it so? Because there are nutrients there that can sustain their growth. There's potassium, there's what? Phosphorus. And these two nutrients, plants need them for the synthesis. So once you see a water body that nutrients are so high, you see these plants floating on water. See them plenty because they have enough of these nutrients that will support their growth and development. And so now, why is it a problem? It's a problem because this takes those plants that are found floating on water. Number one, they may block light from reaching or going deeper into the water so that other aquatic plants may have access to. Two, they may absorb what we call dissolved oxygen. So most of those animals that are in water may lack oxygen and they may starve to death. And when these plants die, they decompose. Okay, so there's so much environmental challenge to this prevalent issue called eutrophication. So when industries release waste into the water bodies without regulation, runoffs from farms, domestic waste, so anything that may increase the enrich the nutrient of water will also give room for eutrophication. Next slide, please. Next slide. Lakes and reservoirs are also susceptible to negative impact of eutrophication because of their complex dynamics, relatively larger water residence times, and their role as an integrating sink for pollutants from their drainage basins. So the quality of water necessary for human use varies, as do the criteria used to assess water quality. So you always discuss for soil yesterday, the same thing applies here. So the quality of water varies depending on the use. So if I'm going to build my house, I will not need to go and buy water from the water factories in town to go and build my house, because that water, I don't need to go and start to maybe take the water to the lab to go and test for microbial load, to go and test for chemical parameters and heavy metals. No, I will not need to do that. Because of what? I am using it for a different purpose. But if I'm going to use the same water for what? To cook, then I'll check for the quality of the water or to drink. So most of these factories that produce water in the state, often the government visits them. Please, Miriam, mute your mic. The government visits them to check whether they are still maintaining the standards that they sign papers to office that they will maintain. So, for example, the highest standard of purity are required for drinking water, whereas it is acceptable for water use in industrial processes to be of less quality. Mariam Ali, please mute your mic. So next slide, please. Next slide. Then now, what's the definition of water quality? We say, in view of the complexity of factors determining water quality and the large choice of variables used to describe the status of water bodies in quantitative terms, it is difficult to provide a simple definition of water quality. So for aquatic environments, is defined as a set of concentration, specification, and physical conditions of inorganic and organic substances. So the composition of and state of aquatic biota in the water body, so description of temporal and spatial variations due to factors internal and internal toward the water bodies. So that is it for aquatic environment. Then, for pollution of the aquatic environment, introduction by man, directly or indirectly, of substances or energy will result in such disastrous effects as harm to living resources, hazards to human health, hindrance to aquatic activities, including fishery, impairments of water quality with respect to its use in agricultural, industrial, and often economic activities, and reduction of amenities. So that is it about pollution of aquatic environment. Now, if the aquatic environment is polluted, where basically it's mostly the source of water in developed countries, then the challenge, the effect will be a chain reaction. Yes. because not most persons in developed countries don't even have money to some persons don't even have money to even dig a hand dug well. Talk more of a borehole. So this depends on the streams and lakes to get water, because this involves finance. You dig a well, you have to pay the person digging the well. You have to buy materials to maybe bend bridge to build the well. So it's expensive. So most of them will not have access to this source of the water. So they will depend on streams, lakes, and other surface water to depend on. Next slide. So water quality of any body of surface or groundwater is a function of either both natural influences and human influences. Without human influences, water quality will be determined by the weathering of bedrock by minerals, by the atmospheric process of evapotranspiration, and the position of dust and soil by wind, by natural leaching of organic matter and nutrients from soil, by hydrological factors that lead to runoff, and by biological processes within the aquatic environment that can alter the physical and chemical composition of water. Now, can anybody tell us the meaning of that word, evapotranspiration? Hello? Hello?
Yes, sir. We're hearing, sir.
Yes, ask a question that what is evapotranspiration? Okay, Simon.
Yes, evapotranspiration is the combined effect of loss of water from water surfaces, the soil, and then the plant back to the atmosphere as a result of the increase in temperature, sir.
Okay. Any other person? Any person with a different opinion or view? Any person with a contra answer? Or do you all accept the what Simon just said? Yes, I love that. You see, transpiration in plants. You see, it is said that transpiration is a necessary evil in plants. The reason being that plant must transpire, otherwise they will die. That's why it's a necessary evil. If plants don't transpire, they will die. If they transpire in essence, they will still die. So transpiration is the loss of water in form of water vapor. So what that statement is saying is this, that as usually observed, the variance in temperature will determine or affect the rate of evapotranspiration, because water will evaporate into water vapor and to go up. Then as water moves to the plants from the roots up to the leaves, plants also lose this water in form of water vapor. We call it transpiration. Though when it's in form of water droplets, we call it guttation. So this coupled with the biological processes and hydrologic factors, okay, can alter the chemical composition and physical composition of water. So it's very important because these processes it's a constant process that have direct contact with water. So next slide. We have 2 minutes to stop.
Next slide. Once finish this slide, we now go for break to resume for afternoon session. So water quality typically is determined by comparing the physical and chemical characteristics of water sample with water quality guidelines or standards. Now, there are regulatory bodies, as we said yesterday, that have the statutory responsibility of setting standards. Okay, then there are bodies that will enforce these standards, and they are backed by what? Laws. So we defined what the standard is yesterday. Now, what our first paragraph is saying says this: if you get your water, you will test it. We are coming to that, but according to how you test water, you test it. Now, after testing this water, you now make a comparison. You check this value I've gotten and the one that it's accepted as a standard by the standard. Is it up to? Is it more? Is it less? Is it the same? Before now make your judgment based on what the result gave you. That yes, it is more. So if what is more, it is not accepted. It is less. Yes, it's because less is accepted. So drinking water quality guidelines and standards are designed to enable the provision of clean and safe water for human consumption, thereby protecting human health. These are usually based on scientifically assessed acceptable levels of toxicity to either humans or aquatic organisms. So remember the first statement that told us that access to water is a fundamental human right declared by United Nations. So that paragraph is saying that these standards are set so that water that you have access to is clean, is safe from any pollutant for you to consume. So by so doing, human health is protected. So these standards are set based on what science have assessed. Okay, they have assessed it, they have checked over time that okay, if this is taken into the body at certain level of toxicity, then this will happen. If not, this will happen. So normally they use the albino mouse or mice to do this experiment before coming out with this result. So any question before we go for break? I think the break is by 11 to 1 or 11. Please, what is the break time? So that we're on the same page.
11, sir. 11.
Oh, that's good. I know. I remember when I was in primary school. One is big. Before we can't start running for break. So it's break time. So I'll go for break. So this today.
Thank you, sir.
If you come back, don't go and eat too much so that you participate in the lecture very well. Okay. Just take something light. Thank you.
Okay, sir.
Thank you, sir. Thank you, sir.
So see you then.
Okay, sir. Sir, you can join us for the break. Oh.
Okay, thank you very much. Thank you so much. I appreciate
Thank you, sir.
Okay, because I complained yesterday. So
Yes,
today
sir.
you're inviting me.
Yes, sir.
That's okay. That's okay. Thank you so much. All right.
You wake up, you see all these people here. When you speak, you can come back to your. A big person here. Now they carry boots, they actually carry boots. You know the small thing. Yeah, I go beat them. Yes, yes.